Hey folks, we're going to take a look at one of the investigative tasks from a previous year's AP exam. Now, I understand that there's not going to be one of these investigative task type questions on this year's exam. However, the time allotted for this type of question was about 25 minutes, and that is going to be the timing for one of the free response questions on this year's exam. So this is more of us to get a sense of the timing for a particular free response problem and the different levels that the answer will have. I picked this one because, as far as an investigative task goes, I didn't think it was terribly dramatic, and therefore a fair type of question ultimately that you would see on this year's AP exam, because it's not really stretching beyond the scope of what we've talked about in class. Yet you ought to, have a good gauge of what 25 minutes feels like to go through the problem. So I want to go through this one. I'll give you a couple of problems similar to do. I wouldn't say dive into all the question sixes from years past, because some of them, as far as applying new ideas, they are pretty out there. And so I tried to pick ones that were more accessible and what I would expect to be more like problems you would see this year. So in 2015, there was this question. Corn tortillas are made at a large facility that produces 100,000 per day on each of its two production lines. The distribution of diameters of the tortillas produced at line A is approximately normal. We like that, with mean 5.9. And the distribution at B is also approximately normal with 6.1, and we can see that here. Here's the average of B and the average of A. And without thinking too hard, the spreads seem to be about the same. So we're looking at somewhat roughly equivalent distributions here. Just one happens to be shifted from the other. Let's see. The tortillas produced at the factory are advertised as having a diameter of 6, which is really the average between those two. For the purpose of quality control, a sample of 200 tortillas is selected and the diameters are measured. From the sample of 200 tortillas, the manager of the facility wants to estimate the mean diameter in inches of the 200,000 tortillas produced on a given day. So two sampling methods have been proposed. Method number 1 is take a random sample of 200 tortillas from the total produced on a given day, meaning, right, there's going to be 100,000 that come from this guy, and then 100,000 also come from that guy. So take 200 of those and measure all of them. Versus method 2, randomly select one of the two production lines. So either from A or either from B, pick one of them and take a random sample of 200 from their individual 100,000 tortillas and measure the diameters. So you randomly select one of the two and take 200 from one of the production lines, or you take all 200,000 produced by both and randomly select 200 from that total. Those are the two choices we have. Question A says, will a sample obtained using method 2, so that's where you randomly select one of the two production lines, will that be representative of the population of all the tortillas made that day with respect to diameters of the tortillas? Explain why or why not. So we're only choosing from either this 100,000 or that 100,000. So is it representative of the population of all tortillas made that day? Well, no. Hopefully you're saying to yourself, no, I'm either choosing from this group or I'm choosing from this group. Not every tortilla had the same chance of being selected, or subset of 200 total tortillas could have been selected. So we've got a problem there. They're only going to be representative of the production line from which they came. So as far as your explanation goes as to why, you're only selecting one production line. Something to that effect. Not selecting from all 200,000, you're only selecting from the 100,000 from that production line. So something a little bit more eloquent than that. I'm going to be tight on space. But the answer is no. And then you're only selecting one of the production lines, right? Therefore, not representative of all tortillas made that day. The other production line has, on average, different diameters. So something like that. That's part A. Come down to part B. The figure below is a histogram of 200 diameters obtained using one of the two sampling methods described. Considering the shape of the histogram, explain which method, method 1 or method 2, was most likely used to obtain such a sample. So we've got roughly 6 in the middle there, and I'm kind of seeing this little shape there, and another symmetric bell shape there, roughly. So it looks like, to me, that it wasn't just one of the production lines being selected. It looks like tortillas were selected from both to get this, what else I'll say is roughly bimodal looking shape here. So part B, we'll say method, and if we go back, that was 200 from all. So that's method 1. Method 1 is likely, right? Most likely. Most likely. And why? Why would we say that? Well, the center tends to be at about 6 inches. Range from 5.75 inches to 6.25 inches, or whatever you want to mark it off at. So we've got the center, we've got the spread from that range there. Doesn't seem like there's any outliers, but then also this this shape, this two-peaked shape of the distribution. Likely not to have come from one production line. Maybe you go on to say that each of those production lines, as each is approximately normal by themselves, and in this sampling distribution or simulated sampling distribution is not. It's not approximately normal, where if you were to have used method 2, you would likely have gotten something that looked like a histogram just around 6.1 or similarly just around 5.9. So however you want to say that. Tight on space here for C, but C says each day which of the two sampling methods, method 1 or method 2, will result in less variability in the diameters of the 200 tortillas on a given day. And so we kind of made the argument in the previous answer. So it's not going to be method 1. In this case, method 2, where you only select one of the production lines. Right. Method 2. Only selecting one production line will result in less variability. So that was method 2. Likely to only have one peak. Therefore, smaller standard deviation or overall spread. Right? If there's only the one peak, then most of the data is close to the center, right? Which is the definition of standard deviation. The smaller the standard deviation, the more the points are closer to the mean. In a picture like this, where the mean is right in the middle, well, most of the data is actually farther away from the mean, so that's going to have more spread, and that was from method 1. So to have less spread, method 2 seems to make sense. Let's see. Each day, the distribution of 200,000 tortillas made that day has a mean diameter of 6 inches with a standard deviation of 0.11. So this is our sigma, and this is mu, because we're talking about the distribution of that many made on a particular day. So that's our population. For a sample of 200 from one of the days, describe the sampling distribution using method 1. So method 1 was, I gotta remind myself, where we take 200 from the total. Okay. So, let's see. First, describe the sampling distribution. So I want shape, outlier, center, and spread, but outliers are probably not here nor there when it comes to the sampling distribution. So shape, center, and spread. The shape is going to be approximately normal, even though it comes from, these two different groups, and it was ultimately bimodal to start with, because n, which is 200, is greater than or equal to 30. Central limit theorem tells us that the sampling distribution is going to be approximately normal. The mean, or the center, and when we talk about center, we want to talk about the thing we know, and we happen to know that the mean of the population was 6 inches. Therefore, mu of x bar, which is equal to mu, is also going to be equal to 6 inches as an unbiased estimator. The mean of the sampling distribution is equal to the population mean, so 6 inches. And then the standard deviation, or the spread, but we know it's standard deviation, standard dev, that is equal to sigma over the square root of n, so 0.11 over the square root of 200. And really, if that were the answer, you could likely leave it that way, because one of the things they said about this year's exam is the calculator is not needed. You might want it for some four function stuff, but which we'll do, because I imagine most of you will have it as you're taking your exam. But in any case, looks something like that. So the standard deviation of the sampling distribution is equal to sigma divided by the square root of n. Question E. Suppose that one of the two sampling methods will be selected and used every day for a year. The sample mean of 200 diameters will be recorded each day. Which of the two methods will result in less variability in the distribution of the 365 sample means? So this is maybe where it starts to get away from us as far as things we talked about specifically during the year. But again, as far as investigative tasks go, I don't think this one's out of our reach, but something for us to think about. So we have the choice of taking the two different distributions collectively, or the production lines, excuse me, that bimodal distribution every day, or we can randomly pick one of the two production lines and sample from that one on each day. But on day one, I may choose production line, what was it called, A? So I might choose this guy on day one, this guy on day 2 and 3, and then this guy on day 4, and so on. So that would be method 2. And if I'm bouncing back and forth, over the course of 365 days, just to maybe give you an idea of what's going on, I'm likely to end up with something that looks like that over the course of the 365 days, versus if I were to use method 1, as we saw that from part D, it'll turn out to be approximately normal with a mean of 6 and a standard deviation of 1.1. So that's actually going to look like this. So between the two, which one has less variability? It's going to be method 1. And we described a lot of the reasons in the previous part, but method 1, for the reasons we described in part D, also to say method 1 is better because method 2 will have distinct means or distributions at 5.9 and 6.1. Two distinct 5.9, 6.1. Whether you go on to say that or not, or just refer back to all the reasons why it would be better because of what you said in part D, that would be fine as well. And you would have more space on the exam to sketch anything if you wanted to make your point that way. So we'll come down to our last question here. A government inspector is going to visit the facility on June 22nd to observe the sampling and to determine if the factory is in compliance with its advertised mean diameter of 6 inches. The manager knows that with both sampling methods, the mean is unbiased. So the mean is always going to be 6. However, the manager is unsure which method is likely to produce a mean that is close to 6 inches on the day of the sampling, based on your previous answers. So everything you've said up through E. Which of the two sampling methods is more likely to produce a mean close to 6? So are you better off picking one of these guys and taking all the tortillas from there, where you would expect to get either 5.9 or 6.1? Or are you better off taking 200 from something that looks like this and hoping for a mean in there? And I think for the reasons we talked about in B and in D, we're leaning towards method 1 here. Method 1. Because even though in the long run, we know that method 2, if you're bouncing back and forth between these two, in the long run, you'll end up with an average of 6. Because we saw that here, right? The average is still 6. I'm looking over here now. But on any one day, you're either going to be probably over there or over there. Where using method 1, you're expected to get 6. That's always going to be your best guess on any given day. So method 1, for all the reasons we said, or again because method 2 likely to have a sample mean close to either 5.9 or 6.1 inches. And we've stated a number of times already that method 1, as we said specifically in part D, that the mean is going to be close to 6 inches. And that would have been the end of the exam there for 2015. We'll take a look at the time, but hopefully that was about right for us on this problem as far as 25 minutes goes. And then you're doing this at home on your computer or iPad, and you'll have some time to make sure it gets uploaded for the test. And then your second question is 15 minutes you'll have for that one. So now you guys are going to try, if you haven't already, the question 6 from 2016 in groups, and you'll do another one for homework tonight before we then, on day 2 this week, discuss and review Unit 1, Chapters 1 and 2.